Hello everyone. I'm gathering some of my power tools. I've got a couple of angle grinders, a drill, and a battery. Let's see if this battery works with my drill. As you can see, the drill doesn't work with this battery, showing no charge. This is a common problem with older batteries, but it doesn't mean it's useless. To test the current charge, I'm connecting a small fan to the battery. As expected, there's no power to spin the fan. This battery is completely drained or has internal issues. Now, let's try connecting the fan to a larger battery. See how strongly it spins. This confirms the fan works perfectly and highlights the complete lack of power in our drill battery. I'll try charging the battery on its dedicated charger. The charger indicates that it's not charging, which means there's a deeper problem than just being discharged. This often points to issues with the battery management system or the cells themselves. I'll put an X on it so we know which one we're working on. To diagnose and fix the issue, I need to open the battery casing. I'm using a screwdriver to carefully remove the screws from the bottom of the battery pack. With the screws removed, I can now open the casing to reveal the internal components. Inside, you can see the individual battery cells and the control circuit board. This is where we'll start our repair work. The first step is to clean any dust or debris from the circuit board and the battery cells. I'm using a small paintbrush for this. A clean surface ensures better contact and helps identify any potential issues that might be hidden by dirt. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. I'm using a screwdriver to open the circuit board on top of the battery to check the wires inside. The internal wiring is still working properly, so I'll reassemble it and move on to the next step. Next, I'm carefully removing the small green protective strips covering the battery cell contacts. These strips are often heat shrunk onto the terminals, so I use a small screwdriver to gently pry them off. Now, I'm applying a generous amount of WD-40 to the exposed battery terminals and the circuit board contacts. I'm wiping down all the contacts and components with a clean tissue. This removes any excess fluid and dislodged dirt, leaving a clean, conductive surface. I'm reattaching the blue insulating material to the battery cells. These are insulators, and sometimes they can interfere with proper connection, especially if the battery cells have shifted. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. I'm taking a piece of sandpaper and cutting it to a manageable size. This will be used to clean the metal contacts. I'm spraying a large amount of WD-40 onto the metal contacts on the battery cells. Now, I'm carefully sanding the metal contacts on the battery cells. This process removes any remaining oxidation or grime, ensuring a fresh, clean surface for optimal electrical connection. This is a critical step for restoring full power. After sanding, I'm wiping away any dust or residue with another clean tissue. We want these contacts to be as pristine as possible for maximum efficiency and longevity. I'm using a heat gun to remove moisture from each battery cell. This helps insulate and protect the battery, preventing short circuits and keeping the battery pack stable and safe. I'm now taking these keys to prepare for the battery recovery charger. I'm stripping both ends of a red and a blue wire. I will attach small metal keys to one end of each wire. This configuration will act as our conductors. Now, I'm crimping alligator clips to the other ends of these red and blue wires. I'm connecting the alligator clips to the terminals of the motorcycle battery. The red clip goes to positive, and the blue to negative. This allows me to use the motorcycle battery to restore the drill battery cells. Now I will connect the key to the battery terminals. The drill battery will be restored by drawing power from a motorcycle battery. I'm disconnecting the wires and the motorcycle battery. I pressed the power button and confirmed the battery cells were restored. A big win. I'm screwing the battery casing back together, making sure all screws are tightened properly to secure the components and protect the internal circuitry. Now I'm reconnecting the battery to the standard charger. The indicator light on the charger is turning red, showing that the battery is charging. Let's check the battery indicator again. A full charge. Our repaired battery is ready to go. To confirm its functionality, I'm connecting the small fan to the repaired battery. It spins powerfully. This is a great sign that our repair was successful. Finally, I'm inserting the battery back into my drill. Listen to that. The drill is working perfectly. This project truly proves that with a little know-how, you can bring old tools back to life. I'm even using a drill to screw this piece of metal in so you can see that the full power has been restored. Our incredible multifunctional tool, made from a simple, previously dead battery pack, is back in action. This DIY device proves that with a little creativity and effort, you can achieve amazing things and extend the life of your valuable tools. If you enjoyed this project and found it inspiring, please give this video a big thumbs up, share it with your friends, and leave a comment below telling me if you've ever repaired a battery pack like this before. Thank you for watching, and I'll see you in the next one.